Let's continue with our top interview questions. Next one is another matrix problem. Okay, start the timer. Rotate image. We have n by n. Rotate 90 degrees clockwise. So 1, 2, 3, 1, 2, 3. Okay, rotate in place. So we are putting each row into each column like this. Okay. N is at most 20. They're all integers. All right. Okay, so we cannot create another matrix and then just simply copy this value into those columns. Do not return anything. It has to be in place. Okay. Okay, so what we need to do is something like this. Let's look at this example. So 5 needs to go there. 5 goes there. So we need to find the pattern with all the indices to make sure that it's rotating to the right place. We need to find that pattern so we can do it in place. So right now the easiest we can see is 5 is going there, 11 is going there, 16 is coming here, 15 is going there. Now these ones in the middle. So this will be row 0, column 1. So 0, 1 would go to 1, 3. Let's see if we can find any pattern for this. So 0, 0. Let's see. Okay, so row 1 becomes column. First row becomes last column. Second row becomes second to last column. Okay. Oh, it's gonna be tedious to write out this whole thing, but I kinda wanna write out all the indices so we can see if we can find the pattern that we're looking for. So this first row would go to first row, last column, row 1, last column, and last row, last column. See, can we use this somehow? Okay. Okay. Okay, what about the last one? Let's see, -1, 0. So this is the last row, and that will turn into the first column. Okay, first column. Okay, let me see if this is the way to find the pattern. Okay, so first thing we notice is that the second index here, 0, 1, 2, until n-1 will be the first index in the result, and the first index is simply 0 for all of this, and then the second index is n-1 for all of those. Okay, let's see if we can find similar pattern. So second row, 0, 1, 2, n-1, we have 0, 1, 2, n-1, so that's the same, and then we have 1, 1, 1, 1, and 1 plus n-2 would be the same as 0 plus n-1, so that seems to work. Okay, what about last one? Let's check one more time. 0, 1, 2, -1, 0, 1, 2, -1, and n-1 plus 0. Okay, so that seems to be the pattern. So if we had index I and j, what would that turn into? So j would turn into the first index, these 0, 1, 2, -1, 0, 1, 2, 1, yes, and I will turn into n-1 minus I, no, plus I. Let's see, so I will be, so I is 1. Oh no, it is minus. Okay, so the sum is n-1, so -1, -1, n-1 minus, yeah, so that seems to be what we're looking for. So each ij turns into j n-1 minus I. That's what I've found so far. Let's see if that works. All right, so in order to not lose any value, we need to just store one of them before we change. So when we wanna move 5 to there, and then 15 will move to 5. We just need to save this 15. So then we can safely move 5 to 11, 11 to 16, 16 to 15, and we know that we saved 15, so 15 can be there. Okay, let's see if we can get this. N by n. So we have length of matrix, that is n, matrix that's n by n. So for I in range n, we do have I and j. Do we need 2 loops or not? Yeah, I guess we need 2 loops. So we're gonna keep the same I and then increment j. So then we're doing the first row. Then we go to I1, doing the second row. Is that the way to go though? Because we cannot, that would not be the right way to do it, because we cannot do the first row and replace them here, because then we would have replaced these values which we need for later. So this is not the right way to loop. Okay. Okay, what if we loop it like this? Since this is gonna turn clockwise, what if we loop changing all the 5s first, and then we do 1, then we do 9. Let me see. Okay. Okay, how could we write so a rotates these elements first, and then these, and then these? Okay. I, J, currently 0. I feel a little stuck. Hmm. Matrix 1. Okay, just trying this out first. Not quite sure if this is gonna work. If we save this, J. Okay. Matrix I. So this is not correct. Let me see. J. Okay, so J. And so according to this, these should be the same. Okay, so let's scratch that. So first we saved this one. Oh, then we need to turn this one here. Okay, we saved 15. And then we'll need to go from here. That will be n minus 1 minus I. So that one should go here. So this one should go to where we saved. Okay. So the J should be, so these two should be the same, and those should sum up to a minus. So this is not right. Okay. Matrix. Okay, let me see. So next one should be this one. So this one should be I and this doesn't match what I found earlier at all. So what is wrong here? IJ. Okay, let me see. IJ goes to Oh, I see. So ij goes to. So that's the ij, and this is the. So it should be like this, okay. So these two should be the same. And these two should sum up to n minus 1. Okay. So these two should be the same. And this will sum up to n minus 1. This should be the same. Wow, it's tricky to know which one is I and J at this point. So we start from, okay, we should be looking at another example, then we will have much clearer idea of which is I and J. Let's look at this one. Let's look at 1 that should go there instead, and 10 that should go here, and 12 that should go there. So we need to save. Okay, let's save 13, then we move 12 there. Okay, we're saving 13. Bad example usually leads to bad results. Okay, 13, we are saving 13. So that is at 2, 0. So matrix 2, 0 is matrix n minus 1, 2. Okay, so that would be when I is 2 and J is, well, it's the same around of I is 0 and J is I 0 and J is 1. So what do we have here then? N minus 1 minus J. I minus I. Wow, this has taken 25 minutes already. Sorry. I feel like this should have gone much better, but it's been such a long day. Don't think I'm thinking so well right now. Okay. I and n minus 1 is I, J and J. That would correspond to our results here. So that should be equal to this after we save it. So what did we save? We saved, this is what we saved. We saved 13. Now we want to move 12 to where 13 is. And then we want to move 10 to where 12 is. So this is 12. And we need index for 10, which would be 1j. So that was sum up to n minus 1, and that should be the same. Okay, so this is where 10 is. Now 1, we move 1 to 10. So 10 equals to matrix I, j. And then ij is equal to save. Okay. Okay. That seems to be the proper logic. Let's see. So I is going from 0, and I is gonna go from 0 to n minus 2, because that's all we need. And then I needs to go, no, so I only goes from 0 to 1, and j will go from 0 to n minus 2. But the second round, we're only doing this little part. Tricky with the indices as well. Oh, looks like we can finish within 30 minutes. Let's try. Okay, I should go from, we just need to do this and this. So n is 2. I is gonna go from 0 to 2. What about j? J is gonna n minus 1 and minus 2 minus I. That will give us a minus 2 here. What about second round? Second round, I is 1, and we honestly don't even need to do more than just, because we just need that one round. So j would only need to be 1. So n minus 2 minus 1 would give us 1. Right, okay, so we needed to go to n minus 2 minus 1. Okay, let's try this. Oh no, I forgot to increment. Cancel this. J is gonna increment and I is gonna increment. Yeah, time limit exceeded because I just created an infinite loop. Wrong answer. Interesting. Case 1 passed. Case 2. Case 2 is doing something weird. Oh, wouldn't it be cool if I just managed to finish within 30 minutes though. What is it doing? Oh, 3, 4, 6. So apparently this inner loop didn't really go. And oh, I see. Okay, so we need to reset J, that's the problem. After this first loop, we need to reset J to start with I think. Okay, let's see. Oh, now it's all wrong. Huh. Oh, what did I just do? Oh my god, yes! Okay, kind of slow. Let's remove the printing because that usually takes a lot of runtime. Let's try once more. A little better, but not much. Let's just try once more. Yeah, I'm okay with that. Okay, let's see. Okay. Alright, so this is my solution. I think it looks short and sweet. We have N, we have I starting from 0. I guess we could do for I in range as well. Yes, let's try that. For I in range. So that would increment I and initiate I. Oh, what did I do there? Oh, right. From 0 as well. Let's try that. Oh, what's happening? Why is it that it didn't give us that error before then? Oh my god, what am I doing? What did I just do? I in range. Okay. Wow, my brain is not working so well today. Oh, much better. Okay. So we have I in range. I mean, we could just rewrite this to for J in range, starting from I and going to N minus 1 minus I. So that's what we need. back to slow runtime again. But this is what we need. I in range starting from 0 to that, and j is gonna start from I to that. And then we just have this rotation with one save. Okay, I'm good with this now. Let's see, no follow-up questions. All right, time and space analysis, let's do that. So we are doing it in place. We are not using any extra space other than just n, I, and j, and save. So constant space. Time-wise, we are doing something like this. We save 15, and then we just move this to place, and then next round we save 14. Oh no, next round is actually 13 because it will be I0, J1. So that will be this one. Then we save 13, we move 12 there, 10 there, 1 there. And then we do 2, we save that. So we're just gonna do this for exactly one time for each element in the matrix. We are not doing anything more that's taking any more loops. So constant, linear time complexity, constant space complexity. Okay, let's just check the top solution as well. What is happening here? First reverse up to down. Swap. Oh, swap diagonally. Like this. Okay. Swap. Reverse. Okay. Very smart, but I don't know how to come up with these kind of solutions. How can we prove that this is it? Let me see. So first we do up and down reverse, then we swap, then we do a flip diagonally. So that means we are doing, so one would first turn in here, and then it will be flipped there. So that is the correct place. What this is, what we are working on, we're changing the element here to be this element. So I think we should probably be able to prove something like this. So if we had matrix I and J, first it wants to do a up and down reverse, what will we change that position into? So n minus 1 minus I and J. So no change in the column, reversing the row. Okay, that's up and down reverse. And then we do diagonally. Diagonal reverse means diagonal reverse means that we are actually swapping the indices. So let's see if this is correct. So matrix I and J would go to j and minus 1 minus I, which is exactly what we found the first time, which is exactly what we're using here. ij is gonna go to this element. Okay, glad that I proved that. So that's good. All right, so I think I'm pretty happy with this one now. Okay, I'll see you in the next one.